Hi there and welcome back to another video. This time we are going to talk about the famous octatonic scale and some of its secrets. What makes the octatonic scale different from the scales you probably use the most, like church modes for example? The first thing to mention is that it consists of 8 different tones as opposed to only 7. These 8 tones are arranged in a special order which you can memorize very easily. 1, 2, 1, 2, and so on, until we reach our original starting note 1 octave above. Therefore its name, octa, meaning 8 tones. The second special feature of this scale is its numbers of roots. Usually a scale has just 1 root, not more. But as we know by now, the octatonic scale is constructed on a pattern that keeps on repeating. Let's see how many repetitions we need to do in order to arrive at our starting note again in an octave position. It is 4. That means the octatonic scale has 4 different root tones, and all of them are totally equal. That is why we refer to it as a poly scale, standing for polytonality. If we start on C, then automatically E flat, F sharp and A are all equal roots to this scale at the same time. When you look at the distances between these roots, it becomes quite obvious that this scale has a strong relation to diminished triads and, by the way, also to dominant chord structures. We are going to reveal this connection in a second. Every scale with just 1 root can be started on any of the 12 tones we have at our disposal. The octatonic scale, however, can only be started on 3 different tones, as it already contains 4 roots naturally. Poly number 1 starts on C. Poly number 2 starts on C sharp. And poly number 3 starts on D. All 4 roots on any of these poly scales are totally equal. Let's talk about harmony for a second. Here is how traditional music theory teaches chord structures. Pick a scale on a root and use the odd-numbered scale tones on top of each other. The higher you go, the more complex the chord structure. And scale tone 15 would bring us back to the root. By the way, this is the reason why a 13th chord is the most complex chord structure in music theory. Now, let's see what happens with the octatonic scale. We go to odd-numbered scale tones, but actually, this procedure puts us into a diminished world. So it seems that we have to find another solution to figure out harmony on this scale. As stated before, we are dealing with 8 different scale tones as opposed to only 7. Let's divide everything up into 2 equal parts. You see that the starting notes of both parts create a distance of 6 chromatics. And furthermore, both parts are the same, but shifted by 6. That is an important relation, which brings us into bitonality. As both starting notes are possible roots in the octatonic scale, we better look into the remaining notes to construct harmony. Before picking any scale tones randomly, let me show you an example to demonstrate the concept that ensures that our scale tones work equally well over both roots. Still remember, that I mentioned that dominant structures would be great on the octatonic scale? Let's try to find some proof for that statement. A dominant structure, in its most simple form, consists of scale tones 3 and -7 over the root, right? Let's find out what happens when we switch to the other root. Interesting, neither the chord structure nor the actual tones have changed over the other root. Magic! But why does this work? Simply because the distance between both notes over the root is also 6 chromatics. And by the way, this works with any 2 notes over the root as long as you preserve the distance of 6 chromatics. According to this 6 chromatics relation, there are 3 options we can choose from, and none of these choices is actually wrong, as context determines everything. But it turns out that E and E flat is the most practical solution. And that is the reason why the octatonic scale is being used over dominant structures quite often, not only in jazz, but even in classical music. Don't forget that this whole thing not only works for C and F sharp, but also for E flat and A, because all of them are equal roots in the octatonic scale. Go to our website and listen to the 3 piano exercises on polytonality in the supplement section. You may also download the PDFs for study purposes. Hopefully, this sheds some light on the mysterious octatonic scale and how you can use it in your own writing. This is Frank from Music Interval Theory Academy. Have a great day and talk to you next time.